The lesson outcome for this video is solving systems of equations by graphing day 2. Okay, so you'll see this first example is a lot like yesterday's. So what I'd like you to do is go ahead and pause the video right away, see if you can graph these two lines carefully, and find the solution to the system. Then I will do two other examples where we're using a different form of linear equations. Okay, so to graph this first line, we're going to write our slope, which is 3, and our y-intercept, which is -7, and we're going to graph that line. All right, so we're going to begin at -7, that's right here, and we're going to move with our slope of 3, so up 3 and right 1, and this is, again, not new to you guys, up 3, right 1, and there is our points. There are our points. And I'm going to go ahead and graph this line like so. Let's see. All right. So there's the first line. The second line, we're going to do the same thing. We need to use our slope, which m equals -4, and b is 7. So we're going to begin at 7. Now this time it's 7 on the y-axis up here where it's +7. And our slope is -4. And remember where that means we're going to go down 4 and right 1. Down 4 and right 1 will get us to this point right here. And down 4 and right 1 again to here. So now we can go ahead and graph that second line. So, sorry, the line kind of appears wherever it feels like, and then I got to move it. And there's our second line. So the solution to this system, you'll remember, the solution is where we have a point that is true for both equations. So where do we have a point that's true for both equations? Right here. So our solution is that point, which is at 2, -1. Okay, so now how about these two equations? This system, same situation, we need to graph the two lines and find the solution where they intersect. This time though, we're in point-slope form. So the first thing we're going to do is write down a point that we know for the first equation. Now remember, the point, we've learned this in previous lessons, is found by using the x-coordinate found here, but it's the opposite of this, so not -4, but +4. And the y-coordinate comes from right here by y, and it's not -3, but +3. And that's our point, and now our slope is that number that's always right in front of the parentheses, which is 2. For our other equation, well, let's go ahead and graph that one. So let's graph the point 4, 3. 4 on the x-axis, 3 on the y-axis. That's going to be right here. And then we're going to use our slope of 2, which is a rise of 2 and a run of 1. So we're going to go up 2 and right 1, and we're going to get to this point right here. So if I graph that line, all right, close. We'll try and move that a little bit here. There's our line. And now we're going to go ahead and graph the other line. So again, our point comes from our x value from over here. So if it's +7, it's going to be -7. And our y value from over here, if it's +1, this is going to be -1. And our slope is 1/2 from right here. So I'm going to plot the point -7, -1. So -7 on the x-axis and -1 on the y-axis. That's going to be right here. And then I'm going to go up 1 and right 2 using my slope. So up 1, right 2, and up 1, right 2 again. And we're going to be able to graph that line. So go ahead and move that around here to right about there. I'm going to move it just slightly. All right, so there's our line. And now once again, we can see that our solution is where the two lines intersect, which is right here at the point 5, 5. Again, this is the solution, therefore, that will make both of these original equations true. It is the only point that would do so. In our last example, we have two equations in standard form. So our first one is 3x minus 2 2y equals 12. And our other one is negative 4x plus 8y equals 16. So we're going to make a teeny tiny table for each of these, and in our teeny tiny table we are going to find the x and y intercepts so we can graph them. In our first one, I'm going to put a 0 in for x to find our y-intercept and a 0 in for y to find our x-intercept. When I put a 0 in here for x, you can ignore, again, all of this right here, and you'll end up with negative 2y equals 12, and ignore it because it's 3 times 0, which is 0. And now we're going to divide that by negative 2. Again, this is not new material here. So 12 divided by negative 2 is negative 6. So negative 6 is our y-intercept. And now we're going to go ahead and put a 0 in for y. So we're going to put a 0 in for y this time right here. Notice that 2 times 0 will be 0, so I'll just get rid of that right now. And now we have 3x equals 12. If I divide both sides by 3, I will get 4. I'm going to plot those 2 points. 0, negative 6 is negative 6 on the y-axis. And then 4, 0 is 4 on the x-axis. And again, we're going to draw our line. All right, so for our second one, we're going to put a 0 in for x to find our y-intercept and a 0 in for y to find our x-intercept. When I put a 0 in here for x, all of this becomes 0, so we're left with 8y equals 16. If I divide both sides by 8, I get y equals 2. So our y-intercept is 2. And now we're going to go ahead and put a 0 in here for y. When we put a 0 in here for y, that becomes 0. So now I have negative 4x. Negative 4x equals 16. So again, if we want to write that one out, we can. And we want to divide both sides by negative 4. We will find that x equals negative 4. So we put that in here. Again, reviewing of graphing lines right here. So 0, 2 is the y-intercept, which is right here. And negative 4, 0 is our x-intercept, which is right here. And we're going to graph that line. All right. And again, the solution to the system now, the solution will be where they intersect, what point is true for both equations, and that in this case will be from the origin we go 2 to the right and down 3, so that will be 2, negative 3.